I'm Alex Nada. I'm CTO at Nobl9. Nobl9 is a tool for tracking service level objectives. The application that we've built is fairly modern in architecture and design. So our custom code is mostly in Go. There's a little bit of Java. We run most of our services in Kubernetes clusters, including inside the cluster. We run our custom services plus a small Kafka plant, Flink, some other services. We host in multiple clouds. So we have a version of Nobl9 that runs in AWS. So the services are primarily running in an EKS cluster. And we have a version that runs on GCP, primarily in GKE. And then alongside the cluster, we use a bunch of services where we prefer to use the cloud product, right? So for example, in AWS, we run an RDS Postgres database, and we have an EFS file system. And equivalently in GCP, we run a Cloud SQL database, and we run a file store, and there's a bunch of other services that we use that are cloud products. But most of what we run and most of what we have to troubleshoot and maintain in production is inside of a Kubernetes cluster. When we started out, we had a tiny team, 4 or 5 people with hoodies coding around the clock. And in that era of the company, we wanted something that was sort of easy to implement, and we went with what is kind of a default solution, right? We dropped Datadog in there. I had quite a bit of previous experience with Datadog, as well as a bunch of other similar products. I had experience with New Relic that was pretty deep in a previous company, but also a bunch of different logging systems. One of the issues we had with Datadog is that it gets expensive pretty quickly. As soon as our workloads started to scale up in production, but also even in just our dev and test environments, it was really difficult to cost manage. And that got us looking around at other solutions. For a SaaS company, the industry likes to see an 80% gross margin on SaaS. The way that typically breaks down for a company like us, this might be somewhat typical, is that for every dollar you bring in revenue, you only get to spend 20 cents on running and supporting that workload. And those are two separate things, right? Running a workload and supporting a workload. In my experience, the rule of thumb is that you get about half and half. So for all of your revenue, you probably get to spend about 10% on your infrastructure and the services that support actual production workloads. Our primary cost driver in Nobl9 is that we calculate service level objectives. So we're fetching data from some observability system, some metrics. We're querying your metrics, querying your logs. We ingest that into our system, and then we calculate a bunch of other time series from it. And then we figure out, what do we need to do? We need to produce some reports for you. We need to chart this data. We need to analyze whether it qualifies for one of the alerts you've configured. That's our primary workload. So our cost scales as our customers create more SLOs, and we look at cost per SLO. And one of the problems that we saw with a lot of traditional metric systems, but specifically with Datadog that we were on, is that it was a pretty big markup. I like to think of it as almost like your observability tax or your monitoring tax on your infrastructure. And what we were finding was that on top of our infrastructure costs that we're paying to AWS, we were paying 15%, maybe even sometimes more, 20% additional to Datadog just to monitor what we're running. My target for that, my goal for that is to make it 10%. Of course, we can tune our services, we can optimize to reduce our compute cost, and we're constantly looking at that, but we're always looking at the biggest component. And 2 or 3 years in to our production workload scaling at Nobl9, we found that the monitoring became the biggest part, one of the biggest parts where it got our attention. And so we really wanted to just try to reduce that to make it cost scale pretty well. One of the things that really appealed to us was the hosting model that groundcover offers. We were in a situation immediately before the groundcover migration where about 2/3 of our cost was still on Datadog, and about 1/3 of that cost was on Amazon Managed Prometheus. And with groundcover, we've been able to replace both of those workloads completely into groundcover. Groundcover can accept metrics even from outside groundcover into the same backends that we host. So we get a much better cost scaling scenario on that. It's staggering but the overall cost reduction is right around 50% total. And that puts us in a very good situation. So I mentioned that our costs in our production workload, the sort of the tax on our infrastructure was somewhere around 15%, maybe a bit higher. And cutting that in half, we're well under the 10% target. That sets us up really well as our production workloads have really started to grow quickly now. As far as I can tell, I think as we grow, it scales slightly sublinearly. So it's a really good scenario for our future growth on production. And on the non-production workloads, same thing. We so drastically reduced our non-production workload cost that we're no longer bleeding cash in that category, basically. We had turned off Datadog in some of our development environments and test environments just as a tactic to try to keep the cost down. If there's let's say, back-end test environment that is mainly used, if we can dedicate it mainly to the use of a front-end team, they might not need deep observability on the back-end services. They're mostly building a front end. They just need a server test environment to run that against that has the latest code, maybe the latest API endpoints, etc. And we were essentially living without observability on those back-end systems because it just wasn't worth it to run Datadog there. But now we have full coverage. So we cut our costs in half and actually increased our coverage on those test environments. The second thing that really intrigued us was eBPF functionality. This is a drop-in. It's a Kubernetes drop-in. We could install this Helm chart and probably get a lot of what we would need. Maybe not everything. There are places where we have to count something right down to the code execution. But for a lot of what we're looking for, the eBPF automatic instrumentation was really appealing. I was really satisfied with the overall effort and time of the migration. Within a couple of weeks, we had most of the stuff up and running. I would say within 2 months, we had pulled the plug, essentially. We're also impressed with the velocity of development that's happening. We see new features, we see improvements. Some of the things that we had identified that we needed arrived fairly quickly as part of groundcover's roadmap that was already defined. So it's been really smooth.